上传品质还 OK 吗？有人在使用 YouTube 在复习的吗？还是大家使用的是 OCW 中文的？ Okay. So let's continue our lecture. I would like to mention one more time that chapter 7 is the most important chapter uh, in material science engineering. All right, because in this chapter you can learn all the orientation of the strain or stress in the materials. So that's how you understand the properties in materials or even in the devices. For example, in the chips or in the like the building or the bridge or even your table or desk or chairs. So you know how the loading affect the materials. All right, so this is really important. And last time we talked about how we prove or how we show the relationship between the stress xy stress component to the new axis x1 and y1, and the procedure is just similar to what we learned before. 95% of the materials science but mechanics of material problems, the improvement in this course, just stress times its own area and then become the force, and using the force to do the balance, or you can say this is force equilibrium. Okay, otherwise you may see this material flying around, because if this is not in the stable or force equilibrium state, it will flying around. All right, so please don't say stress balance. Okay, only force can balance. Okay, the stress is a state, it's a status, okay, of the material. So be careful. All right, so after you do the force equilibrium, and you can learn the equation like this: sigma x1 as tau x1 y1 in the new axis. The relationship between original x and y direction. There's sigma and it's tau. Just substitute all these three known values, and then you can get the new coordinates components. Okay, and then because of it has cosine and sine, so which means that it has a maxima or minima. Oh, sorry, I should mention this is also a typical problem in chapter 7. It gives you certain value of the certain value, three values, three known value, and then you in x and y and tau xy, and then you just determine the new axis, new coordinates component, and then you I would like you to check the new focus plan. For example, y1 plan. If you treat it as a y1 plan, and then you will, if you treat that as a new x1 focused plan, and their sign, their stress, shear stress sign may be different from the sign if you focus on different plans. All right, so this is also need to be careful about this. All right, and again, I just mentioned that that because of cosine and sine, it will give you a maxima or minima. And to solve the maximum minima, we do the differentiation and make it equal to 0. And then we found the solution looks like this. Okay, the solution. So whenever this theta p make equal to this, satisfy this equation, which means that theta p is the orientation that principal stresses occurred. Okay, what is principal stress? Means maxima or minima stress, and the minimum may be the maximum negative stress. Okay, so you can just see principal stress is really important because it also tells us what is the maximum stress, right? So the weak point of the material, what will happen in this orientation? All right. Then we mentioned that tangent x has many infinity figures along the x direction. Then what is x? Actually, it's a rotation angle, right? But in our real world, our reasonable range is 0 to 2 pi. All right. So 0 and 2 pi, you got 3 curves in it. And if you have one solution, how to get a solution? Just give a horizontal line and then swipe it, and then you find it will always give you 2 values. So previously, if you have your cosine 2 theta p, sine 2 theta p, that's the first solution for theta p. And if you just substitute cosine 2 theta p, sine 2 theta p into this equation, and you can get the new sigma x1. Of course, because this theta p here is now principal direction. So your sigma x1 will be the sigma E1. All right. So if you just substitute these 2 values into the equation, you will get this. All right. Then last time, before I just finished the course, I said, yes, we will have the second solution. The first solution, you get this here, and then you will give another solution after pi direction. Okay, pi increment. So what is pi increment? Just adding 180 degree. All right. Yes, you can see that here is just just adding pi. Okay, pi is adding 180 degree. So you rotate this angle to the 180 degree, and you can have the general 广义三角函数的 coordinate 要怎么讲？英文广义三角函数 generalized triangle function. I don't know, sine cosine function. All right, so you just get 180 degree, and this become negative sigma x minus sigma y divided by 2, and this is r as well, but the tau here become minus. Did you see that? So this new form of the new after rotated triangle, we will do exactly the same thing, right? So your cosine is r. Please help me. R divided by minus sigma x minus sigma y divided by 2. So you got this one. So you can compare a little bit solution. So you have new cosine 2 theta p2. You see, this is the second solution. And sine is okay again. All right. So you have the r minus tau xy divided by r, because the tau here become minus. Right. So again, we substitute this to the cosine to theta. This is a sine to theta. All right. So you will have another solution for sigma p2. Okay. So that's the solution 1 and solution 2. And I don't know which one will be the maxima or minimum. All right. We don't know. Because suppose maybe it will be the maxima, it will be a maxima. We don't know that. So after we substitute it into the sigma x1 formulation, and then we can compare. One of them will be the greatest, one maxima, and the other will be the minimum. And then we will know that theta p, well, the greatest one, well, I will name it theta p1, and the minimum one we will say theta p2. Okay, that's it. So if you can accept this, okay. I want to emphasize that it looks like a coordinate, okay, coordinate, just like a coordinate. So it can be the tau, and this could be the sigma. All right, and you can see that this value, x value, always related to sigma, sigma x and sigma y, and the y tau xy things. All right, so very similar to, I mean, you just draw this triangle in the sigma as x and tau as a y axis. Well, these figures just give you an illustration. All right, so schematically illustration. Later, we will give you a very similar coordinate, very similar, okay? But will be a little bit different to draw the molar circle, okay? 好，这边呢，我这边画一个 sigma x 轴，tau y 轴，是为了让这个三角形就是画出来，然后让你有这种感觉，就是说，这边 cosine 是长这样 ，sin 是长这样，然后如果你转了180度的话，会长这样。那等一下会有个非常非常类似的东西，也是一样 sigma， 然后 tau 在这个坐标上，但会有一点点不同。然后我们来那个东西是用来画莫尔氏圆的。那其实基本上，你就可以发现，其实这个东西就是在这个sigma跟 tau 为轴的坐标轴上面转来转去了哈。所以实际上等一下你就会知道为什么它可以用圆来画。Okay, so actually, by introducing this kind of coordinate, x is sigma, y is tau, okay, you can see that actually the orientation of this is actually rotate like a circle, all right? So that's the reason why we can use more circle to draw this, all right, later. Okay, so this is principal stress. So you can see that the sigma x, so if you, well, let me write down this. So if you sigma x plus sigma y, right? And plus sigma x minus sigma y divided by 2. And you substitute sigma minus sigma y divided by 2r, okay? And plus tau xy and tau xy divided by r and equal to sigma x plus sigma y divided by 2 plus r square r. Okay, so you notice that if we substitute one of the solution from the previous page, and you notice that, oh, it looks actually like the average divided by 2 plus r. And if you substitute the other, okay, I just don't want to do it again, all right? And you will get minus r, okay, minus r. Maybe just the same procedure and you can get minus r. So of course, r is the positive, I mean, because it's a distant, right? So r will be the positive value. So plus, minus, it should be maxima, and this is minimum. Okay? And again, you notice that if you sum them not together. Sum them not together. They will cancel each other, and you'll become sigma x plus sigma y. So again, also it's stress invariant. Okay, stress invariant. So, and also the corresponding shear stress on the main plane. So if we substitute the two solutions from the previous page into tau x1, y1, you will get 0. Okay, so in the principal stress direction, you don't need to consider any stress, shear stress. You don't need to consider shear stress because all the stress status has contributed to the normal stress, principal stress. All right， 就是说，其实之前也有教过了哈，就是如果你今天在主应力发生的状况下，最大正向应力或最小正向应力的状况下，你是不需要考虑到剪切应力的 ，OK？ 因为它的所有的应力能量都贡献都跑到整个就是正向应力去了，没有任何的 shear stress， 没有任何的剪切应力，所以你看到代入了以后，答案是为0的哦。Okay, so you can just one thing. Okay, another thing is that maximal shear stress, very similar. Okay, very similar to what we learned. Tau x1, y1. We want to find the tau x1, y1 maxima and minimum. We do exactly the same thing. We do the differentiation, make it to 0, and then we obtain the solution of this. Only if the theta s, this orientation angle, satisfies this formula, this theta s will give you maximal shear stress. All right. So you compare with the principal stress angle. You see, this is 2 theta p. This is 2 theta s. You compare a little bit. Okay, you can compare. We find that what is the theta s and theta p relationship? You see, tangent to theta p is actually inverse and then become a minus, give it a minus sign. So you inverse the tangent to theta p and give a minus sign, you get tangent to theta s. Okay, so you can notice that theta s and theta p they having proper relationship. Okay, if you determine one of them, you can determine the other pair of them. All right. So, okay, you see tangent to theta s, tangent to theta p, very similar, right? The solution just inverse and give it a minus sign. So, 好，这边讲中文，你会发现 tangent 2 theta s 的解跟 tangent 2 theta p 的解长超像的，只要导数给一个负号，它们俩就会一样，所以它们的关系就是导数加一个负号而已。所以呢，这两个人之间的答案基本上，你有了 tangent，你有了 theta p， 你就可以去算 theta s。那我们等一下可以告诉他会怎么做。Okay, so you can see that after your comparison, you can give a conclusion that actually tangent to theta s equal to minus cotangent to theta p. Tangent to that is actually equal to minus cotangent to theta p. Okay, right. So let's continue. It will be really similar to what we learned. Okay. Again, this is what we learned, right? Tangent to theta s equal to inverse of tangent to theta p and give you the minus sign. Okay, so previously in previous principal stress figure, it looks like this, right? This is tangent. This is tangent solution, tangent figure. Okay, so if I want to get the tangent to theta s figure, what should we do? we need to get this figure become minus cotangent to theta p, right? So what we do here is firstly, we do the inversion. We do the inversion of the tangent x figure. What is tangent x inverse figure? It looks like this. Okay, did you see that? This one is tangent x. If you do the inversion, this line, this point, 0, right, will become infinity, right? But here is from the positive, so it becomes positive infinity. Here comes from negative, so it becomes negative infinity. So you see this point become positive and negative infinity. And here, this is the positive infinity. If you become 1 over positive infinity become 0. Ba-bang. So here, okay, so this point become here. And in the middle, it will be reversed, right? Down. So again, here will become 0, and then you can get this. So you can see this pink line is actually the inversion of tangent x, okay? And then your purpose is going to here, right? So all you need to do is adding another negative sign to the pink line. How to adding, what is the result if we adding minus sign to the pink line? Okay, just reverse it, right? So this red curve will be the minus cotangent x. Okay, so you see this one will be this tangent to theta p equal to minus cotangent to theta p. Sorry, tangent to theta s equal to minus cotangent to theta p, and then you can obtain this red line. And then you notice that actually here and here, their phase difference, theta difference is actually half pi. Okay, so you see this curve, if you move forward for 2 half pi, it becomes this one, right? Or you can say this figure, this curve, go back half pi, become this. Okay, so you know that this is the theta p tangent curve. What will it be if it is minus cotangent to theta p? Their phase actually positive or negative half pi. So it's, this is 2 theta, right? Half pi is 90 degrees. So 2 theta. So the theta p is actually positive or negative 45 degrees. 听得懂吗？我刚刚不是说我们的西塔 P 的图是长这个样子，对不对？我们现在要找的是 tangent to theta S 的图。那 tangent to theta S 的图其实就是 minus cotangent to theta P 的图。OK， 所以呢，我们就来从这一张图来出发，去找 minus cotangent to theta P 的图。首先，第一步要先做导数。 这一条线的导数，这几条线的导数就会变成粉红色的线。粉红色的线完以后还不够啊，你还要再多加一个 minus， 再多个 minus sign 以后，嘣，它就会变成粉红色的图多个 minus sign 就变成下面的红色的线。好啦，那我成功的找到这张图喽。那我们就来仔细的研究这两张图的红色的线。这两条线，其实你可以说是这个东西往前进 half pi， 或者是这一条线，你也可以说是这些线往后退 half pi。所以你的意思就可以看到，其实基本上 tangent 就是西塔 p 的相位，跟应该说 tangent 这个 x 的相位，跟这个 minus cotangent x 的相位差了2/π。那别忘了，我们这边是 2 西塔 s， 那当然就是要再少，就变成4/π啊。那4/π是什么？45度。所以就是说，西塔 p 得到一个值，你要么加45度，要么减45度，你都可以得到西塔 s 的值。Okay, so the angle between the plane of the maximum shear stress and the principal principal plane is 45 degrees difference. All right, so that's it. That's it. Okay, so when you determine principal stress orientation, you can successfully directly give plus 45 and minus 45, and you can get the maximum shear stress plan. All right, so maximum shear stresses, you can get this. All right, your tangent to theta s equal to this one. And then you can do exactly the same thing here, okay? But this time, you can see this is sigma tau coordinate, right? And then you find that, this minus and this is tau positive, okay? So you see here is minus sigma x minus sigma y, and this is tau xy, and this is 2 theta s1. So again, you have cosine, you have sine, you have tangent, okay? And you have r here, okay? So your sine 2 theta will be 2r, well, sigma x minus sigma y divided by 2 over r, okay? And your cosine, your cosine is r over tau xy, okay? Again, you substitute here, you can get tau maxima equal to, wow, 它会自动辨认成这是根号的符号，good. Sigma x minus sigma y divided by 2 plus tau xy 2. Okay, equal to r. Yes, tau maxima is r. Okay, what a coincidence. Okay, very good match. Okay, and again, because you are in a 0 to 2 pi region solution space, 0 to 2 pi region. So again, this is only one of the solution. You can still have another 180 degree more angle. So you can get this, and then you can get minus tau xy and positive sigma x minus sigma y divided by 2. But you will get exactly the same value of this, and you can get exactly the same tau max r. So you can see that although theta s has two solutions, but the resulting r will always be the same. Okay. Now, let's give you a summary of this cosine and sine thing. All right. It will give you maximum normal stress. The theta 1 means maximum normal. And average sigma plus r will be the maximum normal stress, sigma 1. Minimum normal stress, sigma 2. It is sigma average minus r. And maximum shear stress, only one value, r. All right, just r. So you can see very, very good, right? You can see this is not really difficult to memorize it. Average plus r minus r, maximum shear stress r. Okay, so it's not bad, right? And there's a quite interesting. Maximum shear stress is half of the principal stress difference. Well, you just minus it, minus two of them, sigma 1 minus sigma 2, and then you will have 2r, right? 2r divided by 2r. Well, this is just things that the scientists found, but it's when you see the formula, it's nature, right? 很自然嘛，哈。你看到那个式子加总起来，相减起来就会得到2个 r， 那2个它除以2就是跟 r 一样，好，所以这本来就是这样。好 ，OK， 好，我觉得这应该都可以理解，好，可以不难不难。我觉得第7章就是不难，那但是它很重要，那它会有一些自然而然的观念，然后觉得还蛮有趣的。那只要你理解它，应该都没有问题。I think chapter 7 is very elegant, beautiful, okay? Because things are not that complicated like chapter 5, but everything comes just like a puzzle in the right pieces, and then you can get a really good puzzle for that. Okay, so this is the example. The elements has the shear stress minus 32 MPa for the x direction, x positive surface. All right, and this is known, of course. Okay, and here is 30 MPa, and this is positive. Oh, 30 MPa is compression, and along y direction, and x is 84 MPa, which is tensile, and it asks us to draw the principal stress. I mean, find the principal stresses and show them on sketch, which means that you need to plot the element, stress element, and tau mix. Show them on sketch. Okay, let's do it. So firstly, all we need to do is get the theta p, right? How to get theta p? Tangent to theta p equal to 2 tau xy divided by sigma x minus sigma y. So, okay, be careful. 2 times tau xy. What is tau xy in the x direction? 32, right? But minus 32. You need to be really careful about this. The sign here is crucial. Sign is crucial here in chapter 7. Very important. And sigma x, okay, sigma x is 84 MPa, but it's tensile, right? Minus sigma y here is compression, so it's minus 30. Minus 0.5614. So it gives us theta P equal to minus 14.7 degree. And we know that another solution theta P equal to minus 14.7 degree plus 90 degree, 75.3. Okay? Again, you know that sigma 1 and plus sigma 2 equal to sigma x plus sigma y, right? So which means that they has 90 degree differences, and you can see that the triangle is rotating 180 degree, right? So in the real world, 2 theta 180 degree, one theta p difference will be 90 degree. Okay, but we don't know this is sigma p1 or this is sigma p1. We don't know it yet. Okay, we don't know. We need to find out. We need to substitute this value into, well, into the solution, the function, and then we will know which one is the greatest. All right, so let's take a look. So if we substitute theta p, the first theta, well, 75. Okay, so let's substitute. So theta p, the second one, 75.3. We substitute to sigma solution formulation. Okay, 27 plus 57 cosine 150 degree 0.6 degree. So you can see 150 degree, 150.6 degree is the 75.3 times 2, right? And then we can, and also we need to minus 32 times sine 150.6 degree equal to minus 3.84 MPa. Okay, so now we're sort of sure that this is actually 2. Okay, minus 3.3, minus 38.4 MPa. Okay, and how about the theta P1? We do exactly the same thing. Okay, so I just I don't waste the time to substitute then 92.4 MPa by substituting this into this into here and here. All right, or you can use another way to do that. Anyone? We don't need to substitute. How to determine this quickly? Anyone? Bonus. Use what kind of formulation? Anyone? Bonus? We don't need to substitute minus 14.7 because if we obtain this, how can we obtain this one quickly? Anyone? 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 Remember the stress has some properties. Yes. Sorry? It's not related to shear stress. It's related to normal stress. Yes, it's called stress in. Yeah, you are right. So okay, I will tell you. This anyone wants the name of it? Bonus. He said what the answer of he says right. Sigma x plus sigma y equal to sigma 1 plus sigma 2. Or sigma p, yeah, sigma 1, sigma 2. So it's called stress invariant. Oh, you all have 2 bonus. Good. So you have what's your name? Sorry, what? I know your name. Sorry, your number. 111 613 006. Okay. Thank you for trying. I'm really appreciate that you all of you giving me answer. This is really nice. Yeah, very nice. So 感谢大家就是讲，就是回答问题是很棒的，谢谢谢谢，很棒。那这边其实要讲就是我们要怎么样不用带-14.7度，还是可以得到92.4呢？其实有一个叫做 stress invariant 的，对不对哈？就是你的sigma one 加 sigma two 会等于 sigma x 加 sigma y， 还记得吗？所以说这三个值都有啦，那你就可以直接算出这个啦，对不对哈？叫做 stress invariant。Use stress invariant variant，OK，这就是很棒的哈。Very good. Okay, very nice. So now we sort of know that what is theta P1 and theta P2 and sigma 1 and sigma 2. So we are ready to draw. Okay, this is a stress element. And the principal orientation will be this is X. Okay, and this is X1, and we call that minus, well, 14.7 degree. Okay, 14.7 degree. And then at that direction, you have a 92.4 MPa. Of course, 92.4 MPa. All right. And then the other position is minus 38.4. Minus 38.4 MPa. Again, you will notice that I didn't write down minus side because I have make the arrow tells me the everything. Okay. And again, I will emphasize that actually, if you draw the X, new X1 as 75.3 degree, it's still okay, right? So if you, I mean, this can be your focus point, main plan, okay, for minus 14.3, well, minus 14.7 degree, or you can say this one is your focus point, focus plan for the 75.3 degree. Both of them are okay. Okay, so yeah, that's the stress element. And yes, you mentioned that shear stress equal to may not relevant in this case. So we don't need to consider shear stress in this case because principal stress will take all the contribution of the stress. So no component left for shear stress. All right. So I will mention here shear stress equal to 0 when principal stress occurs. Okay? When we consider principal stress, we don't need to consider shear stress anymore. All right? Okay. This is kind of supporting information. All right. That's it. So first one, we're done. How about second one? Second one, tell us tau mix. Tau mix. Tau mix to theta S equal to theta P plus and minus 45 degree, right? So theta S equal to 30.3 degree, right? So if I just minus 14.7 plus 45 degree, one of them will be 30.3 degree. All right. So one of the theta S, we have obtained that. After 10 minutes, I will see you each other. Yeah, I will see you again. Thank you. If you have a question, just come here. All right.好，请问。都要看，都看这一版，一个它这个OK，然后它的形状长什么样呢？这个表示在书上，对不对？对，那这个别人这个看不出来。它应该有一张表，就是还有一张图说 x 被它20的。对，就是它一定有，就是这一张表一定会有六十的，然后它那个画的是20的。它一直应该是 x， 我看一下，因为它们这边是30的方，那边是13的方，所以是差25啊。这个收入不一样。OK， 好，好，请问你都是环境分解？我看出来，我后来对，所以他是会用这种工具来收复这种然后我试到12几分钟才出来，刚刚会给自己但是就这个。OK， 那一般这个如果没有写话，这个会说那如果你用迭代的方式，就比如说，这是 low 嘛，对不对？我就直接写，出一个，就直接写60，直接写60，然后这个在4个是看4个里面4个，但我就觉得这个太多。你真正带的吗？你带到40.3.5变成2.5。我们在不知道答案之前，不知道答案这些动作是没办法拿出计算机。我们在什么今天帮我们告诉他，他就等了，他会出现。那是我同时，对，这个丢他的点是已经给了。这样是都算足够。对，所以要怎么？对，你要写4个方程式。 对，那我们如果用代指，就例如说我写一个函式，这个函式叫做 log 或者是那个什么 x 乘上1减 cos 刮弧175除以2x 乘上18减上包，然后我们要受这种东西，我就可以然后减2.0这个函数，然后我开始说 log 等于多少的时候，你就有个答案。然后它是对，抽到0，然后 log 可以出来。这是我小时候的做法。它应该可以写函数，就是你带 x，然后你自己用手调的取得出来。因为我小时候的那个计算机没有那么厉害，可以受，但是很显然的，他现在也没多厉害，他也送不出来。所以我小时候是用就是我自己去取代，然后就越来越像趋近这样，然后就可以得到这个词。啊，就没有随便猜啊，随便猜啊，哎，对，就有点像是那种猜数字啊。对，其他时间是，对，真的，哎，我以前小时候就是这样，然后那时候都没有人教我这件事情，然后就有一次考试考完以后，大家都错，就只有一个人对，就问他怎么，他就是这样带，然后我后来才学到这个方式。好，其实也不会怎么样，就是反正你发现哇，你带这个差超多，你就开始会越来越大，你就会试的更广。然后这些就是后面的小东西，单位啊，那个位数词其实都还好。其实，哎，怎么讲？你懂我的意思。嗨，有的时候没有连的时候，我觉得是不用连上去。我那时候讲，想看，应该是不要把它画上去，应该是不要比较好。就停在这里，对不对？因为我们那张图是一直越靠近最底嘛，对不对？它还没有到，所以不应该放上去的，对，我不应该把它放上去，对不起。还有没有问题？有点问题的话，继续。对，好。
你刚好讲的这个比较你看这个就是比较小众。不喜欢。
诶，你要传号。对啊，我不是在那个开大家玩笑，我是真的很紧张，因为我还没有出考卷，我好紧张。时间很重要。Okay, so thank you for come back and then coming back, and I continue our lecture. Let me take a look next week. Yeah, I guess I can finish this lecture next Tuesday. Okay, so I finish next Tuesday, and then I won't have lecture in Wednesday. I guess I don't have lecture on Wednesday, so you can prepare all your other final exam. And then next Tuesday, next Tuesday will be our final exam. All right. Thank you. Let's continue. All right. So after we obtain 50, sorry, theta p, and we can plus 45 or minus 45. All right. So I use minus 14.7 and plus 45 equal to 30.3. So we can quickly get tau mix, tau x1 y1 mix equal to minus 84 minus 30 divided by, divided by 2 sine 30.3 times 2, 60.6 degree, plus tau xy cosine 60.6 degree equal to minus 65.33 mPa. Okay, that's it. Right. So we can draw a stress element, okay? And we know that this orientation is 30.3 degree. All right. And of course, this is x-axis and this is x1 axis. Okay. And so 30.3 degree main focus plan has minus 65.37. So you can quickly get this direction, right? Because this is positive x1 plan minus y1 direction. So you will get 65.33 mPa in the minus direction. Okay, 65.37 mPa. Okay, so now if you determine this shear, no problem. You can get the next the other side 65.33 mPa, right? And you can get another set because all the shear stress come in pair, right? Okay, so yeah, this is the maximum shear stress direction. Did I finish the problem? Did I do I finish the problem? Yes or no? Yes or no? Bonus. Did I finish? Yes or no? Do I need to continue the calculation? No. Do I need to finish the I need to continue, right? Yeah. Why? Yes. Normal stress, exactly. Very nice. Please tell me your number. 111. 008. Oh, I heard 888 and 666. No 007. Who's the 007? Well, 007 is007 嘛, right? Kind of, let's say, my idol, right? Because I study in the UK, and 007 is kind of iconic characters in UK. Agent, right? It's a gentleman agent and dress up. And he also graduated in the story. He also graduated in University of Oxford. So actually, he is my senior because I also graduated in University of Oxford. So kind of 007, yes. All right, so let's continue. Sigma x1。哎，听懂我刚才讲什么吗？007就是我有问同学啊，大家觉得007，其实007是非常非常老的东西，就是就连我爸那时候的电影都是007这样。史恩康纳莱是他好像是第一，史恩康纳莱不知道大家有没有听过，就是他第一个007，然后他已经死了这样，他已经老死了这样。那但是他每一代都是不同的人演嘛。那最近一部是 Daniel Craig 演的，然后反正007就是他是苏格兰人吧，我记得，然后他毕业于牛津大学，然后他就要穿西装，穿的很正式，然后很 man，然后就这样，然后那我也是牛津大学毕业，然后我觉得说，哎，好像人男生啊，至少是男生，因为他男生嘛，男生好像也要向他学习，因为他走路都很挺，知道吗？他走路都非常的挺，然后不会嬉笑，但他也很幽默，但是我就觉得他在于这种应对进退的上面，我就觉得还蛮值得人学习的，因为他走路很挺。我觉得是值得就是学习的，而且他又是我的学长，因为我也是毕业于牛津大学，还蛮有趣的，运气很好。我觉得很有趣哦。我以前小时候，我念过的我念过的学校都还蛮有名的，就会被拍成电影，知道吗？我以前是师大附中毕业，所以我那时候有一个非常老的片叫做《蓝色大门》，那是第一部高中的就是拍的蛮有名的这样，然后所以师大附中的校园有在那里面，然后台大当然就是一定会有一些东西嘛，那牛津也算是一个，当然会演的在里面这样，例如说哈利波特在那边演的啊，007在里面演啊，然后X 战警在里面演，我真的有看到 X 战警在我上课的时候就看到他们在拍戏哦，蛮酷的。Anyway，好，continue Sigma X1。So we need to continue because we haven't finished yet. Because when maxima shear stress occur, it doesn't mean that all the contribution of the stress will go to the maxima shear stress. It still need to, distribute their contribution to the normal stress. So sigma x1, 84 minus 30 divided by 2, plus 84 plus 70 over 2 cosine 60.6 degree plus minus 32 sine 60.6 degree equal to 27 MPa. Okay, 27 MPa. Sorry, I need to move this to the second line, otherwise I don't have space for the arrow. So 30.3 degree direction will have 27 MPa positive, so it's tensile. Okay, so 27 MPa, and the opposite side also tensile, right? 27 MPa. Okay, the other sigma y1. So sigma 1 again, stress invariant minus sigma x1 equal to 84 plus minus 30 minus 27 equal to 27 MPa. So again, positive 27 MPa. 27 MPa. Okay, done. Okay, good, good, good. Very nice.我们跟大家讲过，牛津大学的一个叫做 Christchurch College， 其实是哈利波特的那个 dining， 就是吃饭的那个地方。我们跟大家讲过这件事情，大家知道这件事吗？哈利波特的那个吃饭的那个大厅是真的，然后我在里面吃过饭。你知道，牛津大学的学生都会被分配到一个学院，就像是哈利波特里面的那个分类帽，葛莱芬多学院那种东西。那个东西其实不是跟那个学院跟我们的工学院是不一样的。他那个学院其实是那个学制的学院，其实是照顾这些学生，所以有学工的，有学医的，有学数学的，都在学语文的，都在同一个学院下。所以你可以看到马粪跟哈利波特虽然不同学院，但他们会在同一个教室上课嘛，对不对？因为他们是不同的，他们即使是不同的系，或就算是同一个系，也有可能会分到不同的学院去。所以那个学院其实纯粹就是照顾你衣食起居的。那这时候你就是他会有一个，我们每个学生都有一个 quota， 就是你可以去邀请你的朋友去你的 dining hall 吃饭。他们真的有个 dining hall。那我的 dining hall， 我的学院的 dining hall 比较小啊，它是就比较小啊，弱弱的，但还是很棒，还是很漂亮。那你就可以去每一天晚上1到5吧，我记得每天晚上都可以，就是有一个正常的晚餐跟正式的晚餐。正常的晚餐就是那种啊，大家随便穿衣服，然后就去夹那个马铃薯啊，然后在那边吃，然后就结束了。结束完以后呢，就会有一个东西叫做正式的晚 formal dinner。什么叫 formal dinner？ 就是你可以邀请你的好朋友去你的 dining hall。这时候就不会是就会有人 serve 你哦，然后你就要穿西装，你的伴侣也要穿西装。那个伴侣可能是你的朋友，可能是你的女朋友，可能是你要追的女生，很好用。好，然后呢，就是你就可以邀请哦，你真的很有面子哎，你就可以邀外面的朋友，就是说，牛津大学的吃饭晚餐哦，然后上面就会是教授们，那教授们当然一定是要穿着西装跟gown。什么叫 gown？ 就是那个学袍啦。你看到哈利波特有学袍嘛，对不对？黑色的那种，然后就坐在那边，然后就会当当当啊吃饭，每一天晚上都有很正式的那个。那这时候你就会发现一件事情，Christchurch 学院的学生就可以邀请带他，所以 Christchurch 学院的人缘都超好，因为大家都很想要，就是拍他马屁，然后叫他邀请你就是进到他的那个 Christchurch 里面吃饭。所以我在那边4年，我终于认识了一个 Christchurch 的朋友，然后我说，你可以带我去吃饭吗？我真的就进去里面吃。但是不得不说，英国的食物就是难吃，英国食物就是非常非常难吃，所以去那边都是吃一个气氛而已啦哈。那我觉得我在英国吃过最夸张的一道菜，就是一个晚餐，就是马铃薯配马铃薯。什么呢？就是他会给你吃马铃薯泥， 在马铃薯一颗一颗，然后再薯条，就全部都马铃薯配马铃薯。然后他们很厉害哦，他们的鸡胸肉都超柴，超级柴，所以对，就会非常非常难吃，就对了。好，但是我去那边吃到的我也蛮习惯了哦。然后我每次，你知道英国的那个最有名的料理是什么吗？叫做 fish and chips。他们的 chips 就是薯条的意思，他们不会叫做 French fries，不是，他们叫 chips。那我在英国4年半吧，我只吃过4到5次的 fish and chips。为什么呢？都是一年吃一次。我每一次都是吃完以后，好恶心哦，再也不吃了。但是一年后，你就会忘掉这件事情。然后有一天去酒吧，然后想说，哇，好久没吃 fish and chips 我们再来尝试一下。好恶心啊！吃完以后又一年，所以我大概吃了4次到5次左右，然后我就对。那我这一次不知道这一次，我说有一天如果再回去英国，我还是会去吃一次 fish and chip，然后再很恶心的去，因为它太油了，然后它炸就是不知道他们的饼皮就是让我觉得是很复合，有点恶心。Anyway，总之我听过一个笑话，就是天堂就是意大利人当厨师，德国人当工程师，然后法国人当你的朋友，类似像这样。然后英国人当你的，还是英国人当你的酒友吧？应该是这样。反正就是有那种天堂就是这样，然后地狱是什么？英国人当厨师，然后德国人当警察。法国人天堂是法国人当警察吧？我猜，因为法国人就是没关系啦，这样，反正都蛮有趣的。然后德国人当警察就很恐怖，然后当然这是刻板印象，这是好笑的。那对，所以英国人当厨师是非常恐怖的事情。好，Anyway，let's go。More circle for plant stress. Um, Here you see for plant stress. So which means that because we are only talk about the XY component, so which means that this figure can just only draw by 2-dimensional. But if you including um, Z direction stress, this small circle may become a circle and then vary in the 3-dimensional space. So, well, just give you this is not everything. Okay, something advanced, more advanced things is maybe we won't teach that. Okay, but I just let you know the concept. All right, so let's use more circle. We can get everything. Everything you learn in chapter 7, you can obtain those values by using more circles. Okay, how to do that? Remember that I give you a 3-star formulation, right? This 3-star formulation, genius scientist, genius mathematician, ancient mathematician, they found that actually if you do the square, we do the square, and then we sum them up together. What will it look like? It will look like this. Okay, if you sum them, square them, and sum them out together, it becomes this one. And then if we define this is sigma average, and if we define this one is R squared, and then you will find that you can transform this into this one. Wow, this actually give you 5-star. Dun, 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 dun. It is actually a circle formula. You see, sigma x1 is your coordinate. tau x1, y1 is also your coordinate. And square, of course, and minus sigma average is your origin of the circle. And r squared is actually the radius. So this is a circle formula. But one thing, okay, I'll give you here. This is the circle origin, sigma average, 0. And this is R, right? But I would like to emphasize one thing, very important here. I will delete this, and I will actually give you downward tau x1, y1. Okay? This is the only difference of the thing. Sigma x1, tau x1, y1. And you need to really, really be careful here. Okay? Positive downward. Okay? And why this is the tau xy, tau need to be downward as a positive? Because it will be related to the rotation. We want to align the rotation direction to make it rotate as the element rotate. OK， 这边讲一下中文，这边要超重要的一个注意就是说，我们的 tau x1 y1 是向下为正哦，向下为正。为什么不采取上上文就好了？原因是因为我们这个要跟那个 stress element 的旋转相符合。如果今天你正的话，你的就倒过来了，你的正常转，你在图的世界上就要反着转。但如果你今天倒过来的话，图正常转，是图的element 的世界正常转，你的 stress 也是正常转，就是末缘的世界也是正常转。OK， 这就是为什么我们要把它倒过来的原因。听懂吗？然后就是等一下你就会发现，其实 stress element 它可以，它如果是顺时针转，不对，讲说逆时针转，那你的图如果是向下为正的话，你也可以跟着顺时针转就可以，你不用反过来。好，这就是最麻烦的地方。OK， careful. So now I will give you step-by-step guideline to draw more circle, right? So now. Again, assume that the horizontal axis is sigma x1, okay, down, positive to the right, and vertical axis tau xy, positive downward, so important. All right, so this is the first thing you need to do. So draw these two axes, done. The second step, mark the location of the center C of the Mohr circle by sigma average tau x1 y1 0. Okay, so you need to you need to draw the sigma average. So this is sigma average. Okay, and tau x1 y1 0. Maybe you will notice that why it always the center always at the sigma x1 axis. Why tau x1 y1 always equal to 0? Well, this is because plane stress. Okay, because the plane stress will always give you this circle on the axis sigma x1. If you are not sigma plane stress, your circle will go a different height, so it will become difficult. All right. So this is the basic. So sigma x1 equal to sigma average, and tau x1 y1 just 0. All right. So you set the point C of the circle, and then you make the coordinate of point A. What is point A? The point A has sigma x1 equal to sigma x, tau x1, y1 equal to tau xy. Okay, so actually the Mohr circle will correlate it to your real world stress element. The stress element sigma x, sigma y. Actually, this plan has sigma x. Okay, wow, and also tau xy. Of course, sigma x, sigma y, and tau xy are known. You know that, right? So this is always the starting point of your problem. And you know sigma x, sigma tau xy, and the focus, blue focus. So you see your sigma x is positive, right? So your sigma x will be maybe here, okay? And this is tau xy. And remember, the tau xy here is positive. So this is positive downward, okay? So this point we call A. And you can imagine that this point A represent the real world plan A, and the state of the tau xy and sigma x will be the sigma x direction, tau xy coordinates. Okay, now you get this, and you need to make another point B. The point B here is this one. Plan B, okay, plan B. The plan B has tau xy and sigma y. Careful, your plan B, surface B is focused now. So your sigma y, again, this is tensile. Okay, no problem. It's still a it is still a positive sigma y. I mean, sigma y is tensile, right? But your tau xy now is negative because this green surface has positive new x1 direction. And this is minus y1 direction. Okay, so this is focus. This is our focus. So it will be minus tau xy. Okay, and you can mark that as a green point, and we will say this is B point. So you see, point in a Mohr circle will represent one particular plan in the real world. And the coordinates of the points in the Mohr circle will be corresponding to the stress state, tau xy and sigma x, or sigma y, okay, on that plan. Now, we kind of ready, right? Because we set 2 points. And you can draw a circle. Sorry, this is not really perfect. Okay lah. Right, so this is a Mohr circle. And very important things. This A in the real world, theta equal to 0. 0 degree. Very important. And point B in the real world, theta equal to 90 degree. I guess you understand this. But, this is really important. In a Moore circle, the theta will double. Okay, so this point rotate to theta equal to 90 degree. You actually get 180 degree rotation in the Moore circle space, Moore circle world. Okay, so in the real world only 90 degree. But in the Moore circle world, you got 180 degree. Okay? And of course, in the circle, you have radius r. So you see, theta equal to 90 degree in this point. And theta equal to 0 degree here. Okay? So now you can obtain every direction, every orientation in this circle. And if you want to get this, you can have the circle degree, and then you can get the theta. You can get theta, and you can get sigma x. You can get tau xy, tau 1 x1, tau x1 y1. All right. So everything you can imagine that you can obtain in this circle. Okay. Of course, your r equal to this one. All right. 听得懂吗？我们圆心就直接就是平均应力 x 跟 y 的平均应力加起来除以2就好。它一定会坐落在轴上。为什么不会跑来跑去？就是也就是说 tau xy 一开始都是0。tau x1 y 怎么讲 ？tau x1 y1 一开始都是0，为什么？因为就是因为这是 plane stress 最简单的 ，OK。好，然后如果你今天不是 plane stress 的话，你这个就会变成立体的，然后在那边跑来跑去，这会超级难的，也不是超级难就是会更复杂。好，那你有这个点了以后呢，你就可以，其实你就可以画一个圆了就可以画出来了。但是画出来这个圆还要有一个起始点这个起始点就是你的那个点跟莫尔斯圆的点，就会是代表现实生活中的元素的一个面，这个是你的起始点，让它定义成西塔等于0了你这样转才有意义对不对好，你这个 sigma x tau xy， 这是这个面上的状态你就可以借由这两个得出一个点，这个点就是你的 A 点的起始点，应该说这个莫尔圆的起始点西塔等于0。那这时候你就可以发现，对面这个90度，刚好也是有它的应力值也都是跟这个是一样。好，那最重要的事情是，圆内的世界你转了180度，圆外的世界也就是现实世界，你只转了90度这边要小心。Okay, so now we just obtained the point A and point B, right? And you know the theta equal to 0, theta equal to 90 degree. So how about if you have a new axis x1, new axis y1, you have theta rotation. So here you rotate theta in counterclockwise. All you need to do, now you have this D point. So you have theta D. You rotate theta D, all right, theta D. All you need to do is rotate theta to theta D in the Moore circle world. Okay, and you can get point D. All right, and you know this equal to theta equal to theta d. Okay, and all you need to do is determine the height of this. 我忽然发现我血糖开始有点过低，我现在好饿哦，所以我现在的笔触是颤抖的。Okay, so you got sigma x1 and tau x1 y1. This value and that value will be this two value. Okay, very easy. And how about this D plane point? D plane point also easy because it will be 90 degree in the real world, but 180 degree in the opposite 180 degree direction. So this is D plane. All right. And also you know that this is 2 theta d. Okay, and of course you know this point and to this point will be 100 degree differences. And this d plane will be theta equal to theta d plus 90 degree. So in the real world, rotate 90 degree. And in the real world, in the small circle world, you got 180 degree more. So this is sigma y1. And this is tau x1 y1 minus. Okay. And you see, yeah, this is tau x1 y1. The same value, but in the pink focused surface, this is minus sign. Okay. All right. So that's how we use Mohr circle. Okay. 哇，糟糕，我好饿哦！我要补充能量。我会这样，血压过低。刚刚就忽然一度就是手开始发抖，然后头不知道，就是脑袋不知道讲什么，没有能量可以那个。你知道大脑是我们提供消耗热量最多的东西吗？就是消耗 CPU 嘛，对不对 ？CPU 要很多耗能，AI 啊什么，人类其实就是一种 AI 嘛。啊，所以刚刚忽然就不知道讲什么，开始有点语塞。But I guess you understand what I'm talking about, right? Because this is an easy concept. All you need to remember is positive downward, first one. The second is that when you rotate in the same direction, real world, you rotate theta. In the circle world, you rotate 2 theta. And then everything left is basic geometry problem. 接下来你就只要去解高啊、三角函数啊、cosine sin 啊，你就可以得到答案了，就根本就不需要那些背公式，这就是完全的图的问题、几何的问题了。All right. Next one, you can obtain again. I would say Mohr circle will give you everything you learn in chapter 7. How about principal stress? Principal stress is maxima sigma x, right? Or minima sigma x. Minima sigma x. So you can immediately tell me where is the sigma 1 here. Sigma 1. Where is sigma 2 here? Sigma 2. And you remember the formula. Sigma 1 equal to sigma average plus a sigma average. Sigma average plus R. Okay. Everything is correct. Okay. Sigma average plus R sigma 1. Sigma average minus R sigma 2. Everything is here. And the best thing is that you design your point A, right? You have your theta equal to 0. So this angle difference will be 2 theta P. And the other will be 2 theta P plus, well, 2 theta P plus 180 degree, and divided by 2 will be the theta P2. Okay, you can get everything in the Mohr circle. So whenever you draw a circle, the circle may shift, but sigma 1 always occur here. Sigma 2 always occur here. So how to determine the theta P? It depending on your starting point. 我说这个圆它会左右移动，然后以后你在算题目的时候，那不管怎么样 ，sigma 1永远就是最右边那个点 ，sigma 2就是永远都是最左边那个点。那你要怎么样知道西塔 P 呢？跟你的一开始那个 A 面是有关系的，就看你的 A 面是从哪一点开始的，当然就可以自动决定你的西塔 P 是多少。Alright, so if you can accept that, maximum shear stress, easy. These 2 points. This, of course, is tau max positive, and this is minus tau max. All right. Again, you remember this is 2 theta P, right? Theta 0 and to the sigma 1, right? So this is 2 theta P. Let's see. 2 theta P. And so this will be 2 theta S. And what is the difference between 2 theta S and 2 theta P? 90 degree, right? And in the real world, divided by 2, 45 degree. So theta S equal to theta P, difference 45 degree. Everything all in this circle, all right? Genius, elegant, right? 所以你可以看到，哇，以前的科学家真是很会发现一些关联性，对不对？哈，你会发现啊，真的耶 ，2 theta P 是这样子嘛？那这是2 theta S 嘛，对不对？那 theta P 跟 theta S 在圆中的世界差了90度，那在现实生活中就除以2，差45度。Very cool. 不难吧？跟第5章比起来，差太多了。但是它又很重要。Right. We only have 4 minutes. I don't know if I can finish this, but yeah, let's continue. Okay, so using Mohr circle determine the stress acting on the element at theta equal to 30. Okay, in plan only. Of course, we don't know how to do that. All right, so the problem looks like this. Sigma x equal to 90 MPa. And this is sigma y equal to 20 MPa. and it has no shear stress. And luckily, this is sigma 1 and sigma 2 status. All right. So let's draw the Mohr circle. Sigma average, we set center at the beginning. 90 plus 20 divided by 2, 55 MPa. And R equal to, wow, 90 minus 20 divided by 2 square plus 0.2, because no shear equal to 0. Square, so equal to 35 MPa. So now we have the center of the Mohr circle. Again, be careful, tau x1 y1 downward positive, sigma x1 right hand side positive, and uh, 55 and 35. Okay, so now Mohr circles is here. Okay, that's it. That's your Mohr circle defined by the center, sigma average 55 MPa, and R equals 35 MPa. Okay, and we need to determine where is theta equal to 0. Where is theta equal to 0? Here, A plan. A plan. Why? Because 0 tau x1 y1, 90 MPa, 55 plus 35, 90 MPa here. All right, so we can set a theta. Well, not set. We can know that theta 0. Put it here. Right. So you will know that later. I mean, tomorrow I will continue. Tomorrow we'll have an exam, quiz, and then we'll continue our lecture. All right. Thank you very much. If you have any questions, just come here.是
非常跟戴老师的是要标2，
要标2，
标
对，
2，想还要再标2，还是跟自己标2？
标，哎，
运作者是